So dear students, now we are moving to the another inorganic competitive session in the form of coordination compounds. This topic is very important if and only if you are very perfect with the previous chapter that we have discussed, that is called D and F block elements, because we know that the main characteristic property with respect to the transition elements is usually the transition metals called as D block elements can form the coordination compounds. Why? Because these transition metals will have the smaller cationic size, higher charge density, higher polarizing power, along with another important thing is they can have the formation of a vacant d orbitals that helps for the donating of the electrons from the ligands into the central metal atom, or it may be the ion, through some definite number of what bonds? The coordinate bonds. That is why the best examples for the D block elements, best example for coordination compounds are the transition elements. Okay. So now we'll move on to the discussion of the which one? The competitive class, this one, that is in the form of the competitive multiple choice questions related to the coordination compounds. Okay, so let us start directly the first one. Okay, first one, a square planar complex is formed by the hybridization of which atomic orbitals? As if we know that if it is square planar, it is having an hybridization of the type, what is that? DsP2. If it is sp3, coordination number 4 here. Coordination number 4 with sp3 hybridization is tetrahedral. But as if it is a square planar, it must have the what hybridization? DsP2 hybridization. Then what that D must be here? So as usual, S is fixed. S itself is X. We know that we have the two things called as Px and then the what? Py. Apart from that, D must be, as it is a square plane, means we should have the either D is x square y square, or it may be the what? Z square. So first, as if what we are preferring is the D z square first, sorry, x square y square we are preferred. After that we are having the what? Dz square. As if only one d orbital means we have to think of the d x square y square. Therefore, the orbitals that has been involved is going to be the s first, along with which and which? Px and py, followed by the last d orbital in the form of which one? Dx square minus y square, or dx square y square. Therefore, it is going to be 1b. Okay. So now let's move on to the second one. The type of isomerism that has been present in the nitropentaamine chromium 3 chloride is. So here the central metal atom is chromium with the 3 as its oxidation state, and the simple ion that has been present is found to be the chloride, whereas the ligands that has been present is found to be the nitro, along with which one? The pentamine, means amines. Cyanide or isocyanide, nitro or isonitrito, thiocyanate or isothiocyanate, they are the best examples for what? The ambidentate ligands. Means they are having a two different coordinating sites. If that be the case, it is having a which isomerism? Linkage isomerism. So we are having structural isomerisms are of 4 types called as ionization, hydrate isomerism, then the coordination isomerism, along with the linkage isomerism. So here the central metal atom is Cr first, with oxidation state of how much? +3 already mentioned. Nitro with pentamine. Nitro means NO2. Okay. Pentamine means 5. Which one? Amines. So this is the coordination sphere which contains a central metal atom along with the ligands. Now the coordination number is 6 for this, 1 + 5, that is equal to this. Apart from that, we are having the chloride here, Cl. Cl, we know that it is -1. So this is -1. Therefore, it is -1 + 3 is found to be the +2. +2 means here it is +2. Here it is. This is the formula of this one. What's the linkage isomer of this? If I have the linkage isomer of this one, means CrONO. What's that ONO? isonitrito, or we can mention that it is called as a nitrito with O. Nitrito with O. Along with, as usual, the same NH3 with how many times? 5 times along with Cl. Means it is an example for a what isomerism here? The ambident ligands exhibit usually the what? The linkage isomerism. Again, 2 is found to be the what? B. Okay. So next move on to the third one here. The most stable, which one? Ion is found to be the most stable complex, or with ion here. What is that here? More the strength of ligand, more is the stability of the given complex. So this is what we are observing according to spectrochemical series, SCS. What is SCS here? It is spectrochemical series. So carbon monoxide is one of the strongest ligand, that you have to remember first. Followed by, we will have the, which one? The CO after we are having. So here according to this, the cyanide is the next one. Cyanide is the next one, followed by nitro-En. NO2 minus, En greater than. Next, we will have some of the examples related to that. NH3, then PY, pyridine, followed by next is water, I think. Water, then OX2 minus, means oxalate, C2O4 2 minus, followed by what? OH minus, then we are having the F minus, Cl minus, Br minus, and then the I minus. What these are? They are referring to the what? They are the, it is an arrangement of various ligands in the decreasing order of their what strength? Field strength. They are the crystal field splitting energy. So here, I think, up to this we can say that they are the strong field ligands. From carbon monoxide to ammonia, they are the best example related to the which one? The strong field ligands. And these are considered to be the weak field ligands. Okay. So here, more the strength of the ligand, more is the stability of that particular complex. As if according to this, we are having a cyanide here. Cyanide is greater than, apart from that we are having, which one? Water we are having, Cl minus we are having, and then the OH minus here. After cyanide we are having, I think, ammonia, not ammonia here, it is the water. Water, followed by, which one? OH minus. The last one is what? Cl minus. Therefore, more the strength means which is having the more strength here, it is the cyanide. Hence we can say that it is FeCN6 with what minus? 3 minus is one of the stable ion or the stable complex ion because it is having the more crystal field strength. Or indirectly we can say that it is having a more crystal field splitting energy. Okay. So that is 3C. So next is ammonia forms the complex ion. What is that? Cu. NH3 4 times with 2 plus with copper ions in alkaline solution but not in the acidic solution. Why? What is the reason for this one? Usually copper sulfate of solid, when it is added with water in the form of liquid, it forms CuSO4 of aqueous, or indirectly we can say that it is in the form of CuH2O 4 times with SO4. This is the blue colored complex here. So here this has to be carried out only in the alkaline medium but not in the acidic medium. So here when it is treated with ammonia or ammonium hydroxide, so here we are having Cu NH3 how many times? 4 times with what? SO4. Means it has to be carried out only in the what medium? Alkaline medium. But we can't use the acidic medium. Why? Acidic medium refers to what? H plus. H plus combines with the what? NH3 to form NH4 plus, which is not a ligand. Means if the same thing has to be carried out in what medium? Acidic medium, the H plus ions in that acidic medium readily combines with the base called as NH3 to form the ammonium ion, and that ammonium cannot have the coordination with the which ion? Cu2 plus. Therefore, What are the options here? In acidic solutions, the protons means what? H plus, coordinate with the what? Ammonia molecules to form a respective ammonium ions, and then the ammonia molecules are going to be available or unavailable here. There is no availability of NH3 when it is having the acidic. Hence we can expect it is going to be the what? A. That is 4A. Let's move on to the fifth here. One mole of the complex, what is that? CONH3 5 times Cl3 gives 3 moles of ions in the dissolution with the water. 1 mole of the same complex reacts with 2 moles of AgNO3 to yield 2 moles of AgCl. Therefore, what must be the structure of that? So here the complex that has been provided for you is going to be NH3 5 times with what? Cl3 is one complex that has been given here. This contains how many ions? 3 ions. 3 ions means NH3 can act only as a ligand but not the, which one? But not the part of hydration or part of ammoniation we are calling. If it is a water, it is called hydration. If it is ammonia, it is called as ammonolysis, and the process is called as ammoniation. So here CO, I think NH3 is fixed for you. Why? Because NH3 has to be inside that. As in the coordination number of cobalt is found to be 6 in major cases. You have to remember that the coordination number of cobalt is always usually the 6. Means I can have accommodate only the 1. And I can expect this. If I split this, it is -1, I think it is +2. Here it is -1, here it is 0, here it is +3. Okay? Means how many ions are there? 1 complex ion and 2 Cl- ions. So here 1 mole of this, when it made to react with 2 moles of AgNO3. What is that AgNO3? Silver nitrate. We know that it is one of the confirmatory tests for the chloride radical. As if the Cl- are found to be free. How many are there? Among the 3 chloride ions, only 2 are found to be the free ions but not the Cl- because it is inside the coordination sphere. Before, we can expect 2 times of AgCl in the form of precipitate. Totally I can expect the 3 ions, and when it made to react with 2 molecules of silver nitrate, I am getting the 2 moles of which one? The silver chloride. Therefore, what must be the structure of that particular complex here? CONH3 5 times Cl with outside we are having the what? This. As if there is a readily availability here. Immediately we can tell the answer. Why? Because NH3 cannot be an example for a what? Part of solvation. It is only the acting as a ligand. Only the water can have both but not the ammonia. Hence we can decide it is going to be the 5D. Let's move on to the 6th here. In the coordination compound K4 NiCN 4 times, the oxidation state of nickel is how much? It's very simple here. K4 NiCN how many times? 4 times. What's the coordination number of which one? Sorry, oxidation state of nickel. We know that potassium is alkali metal. Alkali metals is having a +1 oxidation state. +1 into 4, +4. Therefore, this must be -4. Cyanide is what? -1. If it is -1 means -1 into 4 is what? -4. -4 plus something is equal to -4. Therefore, it is going to be the C. Hence, it is going to be the oxidation state of nickel in that complex is going to be the what? 0. Okay. Let's have the 7th here. Among the properties that is called reducing, oxidizing, complexing agent towards the set of properties shown by Cn- towards the central metal ion is Mn plus is the central metal ion. Here Cn- is a ligand. So as if already it is mentioned that it is electron donating. Means it will lose electron, means it is called loss of electrons. Loss of electrons means it is called as oxidation, means it is an example for a what agent? Means it exhibits the reducing property but not the oxidation. Apart from that, it is involved in the formation of a complex salt. Therefore, it is called as complex formation. Means it is not only a reducing agent but also a complexing agent, but cannot be an example for a what? Oxidizing agent. Means I can expect which and which? A and C, or it may be the C and A. Means The ligands can have not only as the reducing agent property but also have the what? Complex formation. Okay. So that is about the 7th in the form of 8. Let's have the 8 now. The coordination number of a central metal ion in a complex is determined by, that's very simple, definition of coordination number. What is that? It's the ligands around the central metal ion bonded by both the sigma and the pi bonds. Now pi bond is not correct here because coordinate bond is only one. Coordinate bond is a special such that a shared electron pair is contributed by any one of the atom, therefore it is not involved in a pi bond. So I think this is also pi bond, therefore this is not correct. Ligands around the central metal ion is bonded by only the sigma bonds. I think this is one. Only anionic, no, it is not only the anionic but also the neutral is also possible, or sometimes it may be a what? The cationic ligands also. Therefore this is not possible, hence we can expect C is the answer according to the definition of coordination number. Okay, that is 8C. Let's have the 9 now. Which one of the following complex is found to be the what? Outer orbital complex. Which is found to be the outer orbital complex? Which is found to be the outer orbital? So directly I will move on to this. In case of A, I think CO3 plus. CO3 plus. What is CO3 plus configuration first? It is 3D7. 3D6 4S0 I think. 3D6 4S0 means as ammonia is a strong ligand. What ligand? Strong ligand. What happens here? In presence of SFL, SFL is called as NH3. How 3D6 can be written as? (3D4S). This is filled, this is filled, this is filled. Means I left with only 2 here because as it is a strong field means it is against the what? Hund's rule according to the VBT. Therefore, I can expect D2 here. Here S is there. Therefore, 4, 3 are of 3 types I think. V. Means it is whether it is N minus 1D or ND. It is previously means it is called as N minus 1. N minus 1 means it is called as inner. Inner are also called as low spin complexes. Low spin complex. Let us have the Mn. Mn charge is found to be, I think, can I write this is Mn minus 6 here, it is plus 4. Therefore, it is plus 2, I think. Can I say that it is 3D5 4S1 4S0, I think. 3D6 3D5 4S0 here. Here, I think 3D can be written as 22100. This is for 3D. Means I left with again 2. Therefore, it is again D2 what? SP3. D2 SP3. Again, it is inner. Inner and then the low spin. Let's move to the Fe. Fe. Fe, I think it is in the plus 2 state, I think. Plus 2 state means it is found to be the what? 3D6 4S0. 3D6 4S0 is same what? D2 SP3 hybridization. Again it is high, or it is also called as low spin. Let's move to the last D. What is that? Nickel in the form of, can I say it is plus 2 here. So here it is 3D8 4S2. Therefore it is 3D8 4S0 here. 3D8 4S0. So I think it is 22220. Here it is S. Here it is 4P. So here, according to the strong field ligand, even though it is, according to the NH3 is a strong field ligand. What is that? NH3. Hund's rule according, again is the Hund's rule, therefore it is 2, 2, 2, 2, 1 left with here. If it is 3 here, this is 3. 1, 2, 3. 3 means it is actually 5. But the coordination number is this. So therefore we can't explain this. Hence the name of this one is going to be the 2, I think 2, 2, 1, 1. Then here it is SP3. This is S. This is P3. Here it is D. Means D is outer. Hence it is called as outer orbital complex, or it is also called as high spin complex. Even though NH3 is a what ligand? Strong ligand. As if there is availability of only one vacant orbital, to make that coordination number as 6 means we can't take the inner D, but we can take only the what? Outer D. Hence we can expect the one of the complex which is going to be the outer, even though it is a strong ligand of ammonia, it is going to be the nickel hexamine with the 2 plus complex. Okay. So I think 9D. Let's move to the 10th here. Coordination compounds have the great importance in the biological systems. In this context, which of the following statements is found to be the incorrect? Which is found to be the incorrect statement regarding the applications, I think. They are the applications with respect to which compounds? Coordination compounds. Cyanocobalamin is B12 and contains the cobalt. Yes, because it is CO3 plus. Cyanocobalamin is also called as ascorbic acid. It is called as vitamin B12 is also called as cyanocobalamin, which is a ascorbic acid and contains a metal called as what? CO3 plus. Yes. Hemoglobin is a red pigment of blood and contains Fe in the form of what? Fe2 plus. Yes, that is also right here. Chlorophylls are the green pigments in the plants and contains the calcium. No, it is not calcium, it is magnesium in the form of magnesium 2 plus. Hence the option is this one. Carboxypeptidase A is an example for an enzyme and it contains a zinc in the form of Zn 2 plus. Okay. All the elements, transition elements are involved in the formation of a complexes, but in case of which one? Chlorophyll, it is not the calcium, it is only the what? Magnesium. Okay. So therefore it is 10C. Next we will move to the what? 11 here. Which one of the following has the largest number of isomers? Largest number of which one? Isomers. So I think A is M A2 BC type, B is M A5B type, C is I think M A4B2 type, and D is M A twice with what? B2 type. Okay. Largest number of isomers. So here it can expect only the geometrical isomers, that is cis plus trans, that is equal to 2 isomers are possible. Nothing about that. So here we can expect only the structural isomerism called as ionization isomerism. Only the ionization isomerism, but not the geometrical isomerism. Okay. Next we will have this MA4B2. Again it is, no doubt it is the ionization isomerism plus along with 2 geometrical isomers, that is called as a cis and a trans. Therefore it is equal to 5. In case of this, what we can expect? As EN is called as ethylene diamine, an example for a what? Bidentate ligand. Then oxalato, they are the best examples for what? Bidentate ligands. So here first, as if it is inside that, we can expect 2 ionization isomerism, and then it is of the form MA twice, means it is having the 2 geometrical isomers plus 2 optical isomers are also possible. Because as if it is MAA twice B2 and MAA thrice have what isomerism? Optical. So here there are 2, what are those? D and L. Here it is cis and trans. Here it is the ionization isomerism. Therefore 2 plus 2 plus 2, that is equal to 6 isomers are possible. Here it is 4, here it is only 2, but not this. It is 4. Geometrical isomerism only, but not this one. Okay. So that is why we can expect, what is that? The complex D is having the maximum number of what? Isomers. Okay. 11D. Let's move on to the 12th here. The correct order of magnetic moments, spin only magnetic moments in this is found to be more the number of N, more is the magnetic moment, because mu is equal to what? Root of who into who? N into n plus 2 in terms of Bohr magnet. Where n is the number of unpaired electrons. N is the number of unpaired electrons. Let us have this. Fe, can I directly mention that as Fe2 plus here? This is Fe2 plus, here it is Mn2 plus, again it is. This is also 2 plus. Okay, all are in the 2 states. I think cyanide is a strong field ligand. Strong ligand. Can I say that is 3d6 4s0. 3d6 4s0. So as it is a strong ligand, means here it is 2 2 2 0 0. Therefore n is equal to 0 here. Next we will have the Mn2 plus. Mn2 plus, here it is a weak ligand, I think. This one is a weak ligand. According to that, it is 3d5 with what? 4s0. Weak ligand 3d5 means it is going to be the 1 1 1 1 1. It is in case of 3d, means n is equal to 5 here. Then we will have the cobalt 2 plus, I think. Cobalt 2 plus. Again it is a weak field ligand. Cobalt means it is 3d7. 3d7 4s2. 3d7 4s2 means it is 3d7 4s0. 3d7 means all 5 first according to the Hund's rule. Then we are having 2 pairs. Means 2 pairs means n is equal to here 3. Therefore which comes first here? Manganese complex is having a higher value of n, hence having a more magnetic moment compared to that of CO2 plus followed by Fe2 plus, where we are having first Mn, then cobalt and then the Fe. I think it is 12C. Okay, means it depends upon the number of what electrons? Unpaired electrons. So 12C, I think. Next 13. The oxidation state of chromium in that complex is very simple here. Oxidation state he has mentioned. Already it is plus 1 given. Chloride is minus 1. Ammonia is 0. Minus 1 into 2 is what? Minus 2. Minus 2 plus something is equal to plus 1. Minus 2 plus something is equal to plus 1 means here it is plus 3. Why? Because plus 3 minus 2 is equal to what? Right side is plus 1. Hence it is going to be the T. Okay. 13. D. 13. Next we will move on to the 14th. What's the IUPAC name of that complex? K4, sorry, K3, Fe how much? C and how many times? 6 times. Plus 1 into 3 is plus 3, therefore it is minus 3. Here it is minus 1, therefore it is plus 3. It is a anionic complex. It is an example for an anionic complex. Anionic complex means the metal has to be ended with metallate. Ended with metallate. Therefore, I am deleting which and which. I am having two options here. Whether of iron or ferrite here, ferrite. With oxidation state of what? 3. Hence, according to that, it is going to be C, but not again this. Means it is called as potassium. How much cyano? Hexacyano with ferrite of what? Plus 3. If it is cationic complex, it is just only the iron. As it is an anionic complex, means we have to mention that in the form of metallate, and that metallate is going to be the what? Ferrite. Therefore, it is 14D. Let's move on to the 15th here. Which of the following compound shows the optical isomerism? M A twice B2, M A thrice can have the optical. A is called as what ligand? Bidentate ligand. Cyanide is a monodentate, no, it is not possible. Chloride is a monodentate ligand, no possible. Ammonia is a monodentate ligand, no, not possible here. Because C2O4 2 minus is a what ligand? Bidentate ligand. And it is of the form, what is that? MAA thrice. That is why we are expecting the what? The B can show the what isomerism? Optical isomerism. What are optical isomers? They are the stereoisomers in the complexes where the mirror images are what? Non-superimposable. Means they must the first, they are the mirror images, but they cannot be superimposed on that. Means it is called as what? Geometrical isomerism. Okay, that is 15 of B, I think. Next we'll move to the 16th here. Which of the following cyano complex would exhibit the lowest value of paramagnetic behavior? Lowest value of what? Paramagnetic behavior. Lowest value of paramagnetic behavior. So let us take A, CO3 plus, B is Fe 3 plus I think, C, Mn 3 plus I think, and D is Cr 3 plus. Okay. So here paramagnetism means here more the value of N, more is the what magnetic behavior? Paramagnetic behavior. It depends upon the number of what? Unpaired electrons. I think all are cyanides. Cyanides are what? Strong field ligands. Strong field ligands means again is the what rule? Hund's rule. Again is the Hund's rule. On that basis, let's have first. Can I say it is 4s0 3d6 here, 4s0 3d5 here, 4s0 3d4 I think here, 4s0 3d3 I think. Okay. 3d6. 3d6 means we know that it is in two form called as T2G and then EG. Here we are having the 3, here we are having the what? 4. On that basis, what we can decide? Here it is. Strong ligand means 2, 2, 2, 0, 0 I think. In case of this, 1, 1, 1. Again is the Hund's rule. Again is the Hund's rule means 2, 2, 0, 0. Next, Mn3 plus. 1, 1, 1 first, then we are having the 2 here, 0, 0. In case of this, here it is 1, 1, 1 with 0, 0. The lower are found to be the T2G and above is found to be the what? EG. So here, N is equal to 0, I think. Here, N is equal to 1, I think. N is equal to 2 here. And here, N is equal to 3. Means, lowest paramagnetic behavior, we can say that it is an example for a what? So it is 16 in the form of what? A. Why? 16 in the form of A. This is purely diamagnetic. Why? Purely what? Diamagnetic. Why? Because all are unpaired. All are paired electrons. Among these, which is having the lowest value here, the lowest value is found to be the 1. Hence it is found to be the B, I think. Means that exhibit the lowest. Of course, this is also lowest, but it is not lowest. It is found to be 0 because all are paired. Means it is an example for a what magnetic? Diamagnetic. But the lowest paramagnetic behavior is observed in case of which one? Fe 3 plus. Okay, that is 16B. Let's have the 17 here. Let's move to the 17th here. The value of spin-only magnetic moment for one of the following configurations of configurations is 2.84 Bohr magneton. The correct one is what? So you have to remember mu is equal to 0, 1 point something, 2 point something, 3 point something, 4 point something, and 5 point something. We are having a fractions. So usually I will write directly that in the form of as if mu is equal to root 0, root 2, root 3, root 8 I think, sorry, root 1 into 1 plus 2, 1 into 1 plus 2 is root 1.73, root 3, root 8, then root 15 I think, then root 24, root 35. That is equal to 5 point something, 4 point something, 3 point something, 2 point something, 1 point something. Here it is going to be the 0. Depending upon n is equal to 0, 1, 2, 3, 4, 5. You have to remember first those values. So these are the, because this is obtained by the formula, what is it? As usual, I have mentioned root of who into who? N into n plus 2. Okay. So here 2.84 means n must be equal to what? 2 means we have to search for a ligand complex where the configuration is having a 2 unpaired electrons. Let us have A. D5 strong field ligand. D5 strong field ligand means What's the meaning of that? Strong field means against. Against means, can I say it is 1, 1, 1, 2, 2, I think. 0, 0. Strong field ligand. Means N is equal to what? 1. We are mentioning that in the form of T2G5 EG0. Means N is equal to 1 here. No, I need a what? D3. Both this and this. Weak field ligand as well as strong field ligand. Both have the same configuration. 1, 1, 1, 0, 0. N is equal to 3. No. D4. Weak field ligand. Weak field ligand means 1, 1, 1, 0, 0. 1, 1, 1, 0, 0. Not 0, 0. Weak field. Means N is equal to 4 here. No, it's not possible. D4 of a strong field ligand. Here it is 1, 1, 1, 2, 0, 0. I think we are getting this. N is equal to 2. If N is equal to 2, I am getting the value of magnetic moment as 2.84. On that basis, we can decide 17 is found to be the D4 with a strong field ligand. Hence, it is 17D. 17D. Okay. So let's move on to the 18th now. What's the IUPAC name of that complex? What's the IUPAC name of that particular complex? CO, NO2, NH3, 5 times Cl2. As usual, the very simplest here. So here it is minus 1 into 2 is minus 2, therefore it is plus 2. Ammonia is 0, nitrate is minus 1. Minus 1 means here it is plus 3. So what is that? Nitrito and then amine. Among that first one is pentamine. Therefore I am deleting which and which here? This and this are deleted here. Whether the coordinating site is a nitro with N or nitro O here. It is a nitro with what? This. Well, along with cobalt is in plus 3 state. Hence it is going to be the one. Means it is pentamine, nitrito, N, cobalt 3, chloride is the IUPAC name for the complex of the type CO, NO2, NH3, 5 times with what? Outside we are having a Cl. Okay. 18B. Next 19. Nickel. Combines with a what? Uninegative. Uninegative. Monodentate ligand X minus to form a paramagnetic complex of the type NeX4 with 2 minus. The number of unpaired electrons in the nickel and then the geometry of that one is what? Are respectively what and what? NiX4 with what? 2 minus. As it is minus 1 means it is I think plus 2. Okay. The number of unpaired electrons in the nickel is found to be what? And it is a monodentate ligand. X minus is a monodentate ligand. And it is found to be the paramagnetic. Means N not equal to 0. Not equal to 0. Let's have that Ni2 plus. Ni2 plus. What is Ni2 plus configuration? I think it is 4s0 or 4s0. Can you say it is 3d8? 3d8. If it is a strong field ligand, if it is a strong field ligand, can I say it is 2, 2, 2, 2, 0? Means N is equal to 0. No, it is not possible, I think. Means if it is a weak field ligand, as it is this means it is bound to be the DSP2 square planar. N is equal to 0, but it is not correct. If it is weak field ligand refers to what? D8 means 2, 2, 2, 1, 1, I think. Okay, this is 3D, then 4s and then 4p has been left. Hence it is going to be the what? sp3. sp3 with how many unpaired electrons are there? 2. N is equal to 2 refers to it is a paramagnetic in nature, and also it is found to be the what? sp3 hybridization containing how many unpaired electrons? 2 unpaired electrons. Therefore the number of unpaired electrons are 2 along with sp3 means it is what hydral? It is tetrahedral. Hence it is found to be the 19D. 19 of what? D. Next we will have the 20th. How many EDTA, ethylene diamine tetraacetic acid molecules are required to make an octahedral complex with a cobalt of how much? 3 plus. Cobalt 3 plus. How many EDTA has to be present? It is based on EAN. EAN is equal to Z minus L plus G. Z means atomic number. A is electrons lost. Here electrons gained. This is atomic number. Okay. So atomic number of cobalt, I think cobalt is, can I say it is 27? Cobalt is converted as what? Converted into CO3 plus by the loss of 3 electrons. Plus, how much I can expect it is equal to the nearest core number? 35 or 36, whatever it may be. So here it is 24 already, here it must be 12. 12 means the coordination number is 6. Coordination number is 6. And EDTA is the best example for hexadentate ligand. It is always an example for a what? Hexadentate. Means already the same molecule has a 6 coordinating sites. Hence, 1 EDTA is sufficient for that. Because 1 means it is 2 into how many are there? That is equal to 6. So for how many EDTA molecules that I can expect here? It is going to be the 8. Hence, the number of EDTA molecules with respect to the cobalt 3 plus ion in forming an octahedral complex is going to be the 1. Okay, that is 28. Okay. The next continuation session are the rest of the MCQs that we will discuss in the second session of this particular coordination compounds. Okay, so thank you. Dear students, again we will have the continuation session for the coordination compounds. So let us start with question number 21. Which of the following has a square planar geometry here? Which of these will have the what? Square planar in the form of geometry. Square planar. As if it is a square planar means it has to undergo DsP2 hybridization. What hybridization here? DsP2 hybridization. I think all are weak ligands here. All are weak ligands. So platinum is actually Z is 78 for this. Okay. Z is found to be the what? 78 with respect to which one? The platinum. All PT2 plus, either it may be the weak field ligand or it may be the strong field ligand, always have the what hybridization? You have to remember very directly, that is platinum of 2 plus complex, not the 4 plus. I don't know about that. Only the 2 plus, either it may be concerned with the weak field ligand or it may be the what? Strong field ligand. They will exhibit the what? The DsP2 hybridization. If DsP2 be the hybridization, means it is an example for a what planar. The rest BCD are the best examples for tetrahedral nature because they undergo what? sp3 hybridization. Okay, so that is a very clear. You have to be very careful. If it is any PT2 plus, all exhibit the same what hybridization. It is the DsP2 having a square planar. Let's have the 22 here. The coordination number and then the oxidation state of the metal element E in the complex is found to be what and what respectively. Nitro group is -1, I think. If it is -1 means it is +1. Oxalate, I think it is -2. So in ethylene diamine is 0. So here it is -2 means how much is equal to +1? Here it is found to be the +3. First, what's the coordination number? So here it is a bidentate ligand, therefore 2 into 2 that is equal to 4. Here it is a bidentate ligand, 2 into 1 is equal to this. Therefore 4 plus 2 is equal to what? 6. 6 is the what? Coordination number, and then what is the oxidation state that I got here? 3. Therefore it is 6 and 3 in the form of D. Okay, because both En and oxalato C2O4 they are the best examples for what? Bidentate ligands. Okay, that is 22 D. Let's have the 23 here. In which of the following cases, 23, in which of the following cases, I think 22 before that, I think I have done 22, okay. Next we'll have the 23. In the following complexes of cobalt, will the magnitude of the delta H naught will be the highest? Will be the highest. How we can decide that? As usual, more the strength of ligand, more is the crystal field splitting energy, and hence more is the what? Delta naught. According to the previous, what I discussed in the previous session about that is the stronger the ligand, more is the splitting energy. Therefore, first can I say that cyanide is stronger compared to the top, ammonia is stronger compared to the top, oxalato is greater than followed by H2. Therefore, which is having the highest value of this one is going to be the cyanide. Cyanide means it is going to be the what? A. 23 in the form of A. Let's have the 24. 24. Which of the following has an optical isomer? This is MAA only. Means I have mentioned only the MA twice B2 or MAA thrice can exhibit the what isomerism? Optical isomerism. Here there is this, but it is only AA, therefore it is not possible. Again it is one, but not possible. Twice, I think this is possible. All are monodentate, therefore I can expect. Means this is of the type, what is that? AA twice B2 type, hence it exhibits the phenomenon called as what? Optical isomerism. 24C. Let's have the 25. 25. Which of the following represents which one? The linkage isomers. Linkage isomers. Linkage means they must have the what? Ambidentate ligand. LCS and CNS are ambidentate. Therefore, I think this is the possible. NO3 is not. PTCl2 no. NH3. Therefore, it is only the what? Cyanide, isocyanide. SCN minus and then NCS minus, NO2 minus and then ONO minus. They are the best examples for what ligands? Ambidentate ligands. Any ambidentate can have the what? The ambidentate will have the what? The linkage isomers. Therefore, it is 25A. Let's have the 26 here. A solution containing what? 2.675 grams of COCl3 and 6 times of NH3, molecular mass is given already, is passed through a cationic exchanger. The chloride ions obtained in the solutions were tested with excess of silver nitrate to get 4.28 grams of AgCl. Molecular mass is going to be 143.5. Therefore, what is the formula of that particular complex? What is the formula of that particular complex here? COCl3 with the 6 times of NH3. Okay. So as if the coordination number is going to be the 6, means it is all the ammonia molecules has to be present inside like this. -1 plus 3, 0 and plus 3. When it is treated with which one? Excess of silver nitrate. How much I can expect? As if there are 3 Cl minus, I can expect here 3 times of what? AgCl. Means here already the mass is given as 267, I think 267.5 grams per mole already given. It is gives rise into 2 into what is silver nitrate here? Silver chloride, sorry, 143.5. That's equal to 420, 430 something, nearly 430 grams, nearly, not exact. Means 430 grams of silver chloride is obtained from 267.5 grams of this one. Therefore, how much it is? 4.28, nearly equal to 4.3 grams. I think 10 times a decrease here, sorry, 100 times. It is 2.675 grams. 2.65 this one means here it is all the chloride ions has to be present only outside, which is possible in case of the what? Without any calculation we can directly, because as if the coordination number of cobalt is going to be the 6, means all the ammonia has to be entered into this, means all the Cl minus has to be outside. Therefore, for the formula is CONH3 6 times with what? Cl3. So that is 26 in the form of what? C. Let's move on to the 27th here. Which one of the following has an optical isomer? Again the same thing. I think directly it is En is not possible. En thrice is possible, but not this and this. 27 it is one in the form of B. Let's move to the 28 here. 28. Which of the following facts, 28th, which of the following facts about the complex CONS3 6 times Cl3 is wrong? The complex is what hybridized? CONH3 6 times Cl3 minus 1 plus 3 is 0 plus 3 I think. Here it is strong field ligand against the Hounslow. Therefore it is 4s0 3d I think 6. What is 0? 3d6. 3d6 refers to strong field ligand means 2 2 2 0 0. Here it is 4s and then the 4p. Here it is we are having D. Yes is possible. Yes is there and then B. Yes it is possible. Yes. Wrong. Though this is correct first. The complex is diamagnetic. All are paired I think. 2 2 2 means it is found to be the paramagnetic. Yes, that's also correct. The complex is an example for an outer orbital. Whether D is n minus 1d or D here, it is n minus 1d. Means it is called as inner. Inner is also called as a low spin complexes. But here is mentioned. Therefore, this is not right. The complex gives a white precipitate with silver chloride, silver nitrate. Because as if there is a Cl minus, Ag is NO3 compact this to form AgCl. Therefore, which is found to be the wrong among that? It is only the D. Hence, it is 28 in the form of D. Let's move to the 29th here. Which among the following is named as dibromido bis ethylene diamine chromium 3 bromide? Bis means twice. Dibromido, I think it is B, 29, B directly. That's the direct IUPAC name for the compound. What is that? It is dibromido bis ethylene diamine with chromium in the form of plus 3 with outside as what? Br minus. Therefore, it is 29, B. Let's move on to the what? 30th. Which of the following species is not expected to exhibit the optical isomerism? Not expected. MA thrice is possible, twice is possible. En, NH3 twice, this is also possible. Because these can have the mirror images with non-superimposable. Therefore, this is also possible, but not in case of this. Hence, it is MA3B3 can have only the geometrical isomerism, but not optical. And another speciality of this one is it is going to be the two types, not the cis and trans, but it is the facial and then the meridional. Means they can exhibit only the geometrical isomerism, but not the what? The optical isomerism. Therefore, it is 30 is found to be the C. Okay. So the rest of the MCQs that for the coordination compounds I will discuss in the next session. Okay. So thank you.